Hello everyone. Today we'll be discussing about the problem 704 binary search. So what the question states here, you can just go through the question here. So you can also go through the example to understand the question better. So I'll just summarize the question here so that it will be easier to understand. So what the question states here, we are given an sorted array of integer nums. You can clearly see here we are given an sorted array of integer nums and a target integer, right? So what is our main goal here? Our main goal is to determine the index of the target in the array using a binary search algorithm. If the target is not found, then we have to return -1. So here target is 9. We have the number 9 here at the 4th index. So we have to display the 4 as output here. That's what they have given here. 9 exists in nums and its index is 4. So here we have the target 2 and the number 2 is not present in this array, right? So the output will be, we have to display the output -1. So 2 does not exist in the nums. So we are returning -1. That's what they have given in the explanation as well, right? So one thing we have to keep in mind, the sorted property of the array allows us to efficiently locate the target using the binary search approach, right? So let's discuss the approach first, and then let's discuss all the edge cases and then write the code, and finally let's discuss the complexity of the code that we have written. Initially, let's discuss the approach. So first thing is, we will be going with the binary search approach here, right? So we'll be going with the approach binary search. So first thing is, we'll be making use of the divide and conquer. So we know binary search splits the array into two halves, right? And it focuses on the half that may contain the target. Also, it will eliminate the other half as well. So it will completely eliminate the other half and it only focuses on the half that may contain the target, right? So that's the reason. So first step, let's go step by step what will perform here. So first thing is, let's start with the 2 pointers. We'll be starting with the 2 pointers L and R. This will be pointing to the this one, start, or the beginning of the array, and this will be starting, this will be pointing to the end of the array, right? And the second step is, we'll be calculating the middle index. So second step is, we have to calculate the middle index. And after calculating the middle index, if the value is at this one, if the value is at nums of m equals target, then we will be just returning m here in this case. And if nums of m, nothing but middle, less than the target, then we will move the left pointer to the m plus 1 to search only the right half. I can write in this way. So first thing is, if the value at nums of m is equal to the target, so if this is equal to the target, I have written m here, then we will return m, right? So second thing here is, first, this is the first thing. Second thing here is, if nums of m here, this one, it is less than target, then what we will do, we will move the left pointer to the mid plus 1 to search only the right half, right? So if the nums of m here greater than target, then what we will do, we will move the right pointer to search only the left half. So I can just write here m minus 1. So these are all the conditions that we need to remember. This one will search only the left half, right here. The third condition, if nums of m equals target, then we'll return m. If nums of m less than target, then we will move the left pointer to search for the right half, nothing but mid plus 1. Here, if the nums of m is greater than target, we will move the right pointer to the to search in the left half, nothing but m minus 1. So this is third step. And the final step is, just give me a condition here. Just give me a second here. The final step is end condition, nothing but if left pointer is greater than right pointer, L is greater than R, then target is not in the array. So we have to return -1 in this case. This is important as well. They have clearly mentioned in the question, if no element is found, then we have to return -1. So if L is greater than R, then the target is not present in the array, so we'll be returning -1. So this is the approach that we are going with. Next, let's discuss the edge cases one by one and then finally write the code. So let's go with the first edge case. So I'll just give here edge cases. Let's go with the first edge case, nothing but single element array. So I'll just consider here input this one. Let's consider this one 5. Let me consider here target also 5 here. So the output will be 0 here, right? So we are finding the element at the first index, nothing but index starts from 0. So the output that we need to get here is 0. This is for this one, single element array. So let me give here single element array. So let's move on with the next, this one edge case, nothing but target at the boundaries. So while I say target at the boundaries, I can just consider here, let me consider here nums -1, 0, 3, 5. Same thing. Suppose if we are having the target, target equals -1, and we are considering two examples here. Let me consider target at -1 and target at 5 here. For this, output will be 0. This is at the 0th index, right? So this one output at the 0, and for this one 0, 1, 2, 3, the output will be 3 here. This is for the target at boundaries, right? Target at boundaries. Yeah. So let's move on with the final edge case. I'll just come here. So just give me a second here. So let's go here. Let's give target not present. So we have, if the target is not present, we have to display -1, right? So I'll just consider the input here. Nums, let me consider 1, 2, 3, 4, some random number, and target, let me give here something 6. So let me give the target 6 here. So 6 is not present in the array at all. So the output will be -1 here, right? So this is for target not present. So we have discussed all the edge cases, right? The first one is single element array. The second one is for target at the boundaries, and the third one is for target not present. So I hope all the edge cases are clear. Let's start writing the code, and I'll explain the code while writing the code itself, and then finally let's discuss the complexity of the code that we have. Let's quickly write the code here. So initially, as we had discussed in the approach, let's initialize the left and right pointers. I'll just give here at L equals 0, start of the array, and right to the end of the array, last index, nothing but here we have considered nums, right? Nums dot length -1. So next step is, let's go with the binary search loop. I'll just quickly make use of the while loop. While L less than or equal to R, if this is true, then only we will be moving forward. So let's calculate the middle index first. Let me give here m is nothing but middle. Let's make use of the math.floor, or let me make use of the double tilde operator instead of math.floor here. So I'll just come here. I'll keep left plus r by left plus right by 2. We are calculating the middle index. After calculating the middle index, if the middle element is in the target, then we will return its index. We have already discussed this one. If nums of m, this is equal to target, then we will just return m. We saw the three conditions right here. So next condition is if the middle element is lesser than the target, then we will search the right half. So this is if nums of m, we can write in this way. If nums of m is lesser than the target, then left we can just give here mid plus 1, and else, so just give me a second here. Else what we will do, if uh, if the middle element is greater than the target, we will search only the left half. I will just give here right equals mid m I have considered, right? Mid plus 1. Sorry, this has to be mid minus 1, not plus 1. So if the middle element is just greater than the target, we are just searching the left half. Final thing is, if the loop ends, then the target is not in the array at all. So we have, in that case, we have to return minus 1. That's what they have given in the question clearly. So sorry. Yeah, this is it. Let me format the code once. Let's run the code. So I hope the code works. Yeah, you can clearly see the sample test cases are getting passed. Let me hit the submit button now. So you can clearly see all the test cases are getting passed, right? So the code is getting accepted. The code works absolutely correct. So let's quickly discuss the time and space complexity here. So the approach that we went with here is binary search. We know that we have already discussed about that one. And the time complexity here will be big O of log n. So I'll just come here. Overall time complexity here will be big O of log n. Why the time complexity here will be big O of log n? Because the search space is halved in each iteration, leading to the logarithmic time complexity. So we'll search only for the we'll search only one half where the target element might be found, right? So that leads to the logarithmic time complexity. Here the overall time complexity will be big O of log n. So what will be the space complexity here? The overall space complexity will be big O of 1 here. So why the overall space complexity here why the overall space complexity here is big O of 1? Because we are considering only few variables. You can clearly see L, R, and even M. This one, we are considering only few variables which are used, requiring this requires only constant space, which leads to the overall space complexity big O of 1. So the time complexity here is big O of log n, and the space complexity here is big O of 1. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.